PreCalculus. Welcome to graphing sine and cosine task cards. This is what you guys did today in class. So hopefully you're taking a second to check to make sure you got it right. And also hopefully everything you got was right. So task card 1 said y equals 1/2 cosine x minus 1. All right, does this one have a reflection? No. Where would we find the reflection in our equation? Right here in front of the whole equation. There's no negative sign here, so we do not have a reflection. Amplitude. Amplitude is the number that's inside of our, or in front of our function. Amplitude is the same thing as vertical stretch or vertical compression. So our amplitude for this guy is 1/2, which means from my midline, I'm going to go up 1/2 and down 1/2. Period. Our typical period for cosine is 2 pi. The only time that changes is if I have a period changer and that goes right here in front of the x, but I have nothing in front of my x and my period stays. 2 pi. Phase shift, that's a horizontal shift left or right. That would be inside parentheses. For instance, if this had parentheses around it, then I'd have a phase shift of -1 or +1, I guess. But for this one, it's just cosine x, so no phase shift. We do have a vertical shift though. Outside of my function, I've got a shift of -1, which means we're going down 1. My midline, therefore, so a lot of people are like, what's a midline? Well, midline is, so here's our regular, let's say the cosine function. Our regular cosine function goes like this. Oops, not quite that high, that fastness here is through on us. So that's what our regular cosine function looks like. And so the midline for our regular cosine function is y equals 0, right there on the x-axis. But as we have a vertical shift down 1 of this, that means my midline of my function is going to shift down to -1. So my midline is not going to be at 0, it shifts with the vertical shift down to -1. It does not shift with a phase shift, just with vertical shifts. All right, and then once we've graphed it, we'll look at the domain and range and talk about that. So first off, when I graph these, I would always put my midline there. If I have a vertical shift up or down, that kind of gives me my center point of where I'm going from. Like I said, for cosine, we start typically up at 1. So typically we're starting here, but it got shifted down, so this is where I would start. But I've got that amplitude changer that says it's 1/2. So instead of starting here at 0, I'm going to start at -1/2, halfway above my midline. At pi/2, I'm going to be on my midline. At pi, I'm going to be 1/2 under the midline. At 3/pi/2, back to my midline. At 2 pi, back to my maximum point, which is at +1/2. And then I can continue the trend. These dots, oops, half mishears, so that we know where to graph it. On the other side, we go to midline, 1/2 underneath, midline, 1/2 above, midline, 1/2 below. So now we've got a good idea that the curve will look something like that. All right, so what is the domain for any sine or cosine? Domain's always all real numbers. That won't be the same for all the other functions, tangent, cotangent, secant, cosecant. They have different domains because they've got domain restrictors. But for sine and cosine, it's a nice steady curve with no breaks, no asymptotes, so it's always all real numbers. The range, however, depends on your vertical shift, your vertical stretch or compression. So for this one, my lowest point is at -1/2, my highest point is at +1/2, and we use square brackets. Why? Because we're going through those points, right? And if we go through those points, we have to include them. All right, that's it for problem number 1. Let's look at problem number 2. Y is equal to -sine x plus 2. First off, do we have a reflection? You betcha. We've got that negative sign here, so that means we're going to reflect it. Sine normally looks like this. No, just kidding. Normally looks like this. If I reflect it then, instead of starting at 0 going high then low, it's going to start at 0, go low, then high. So that black one would be the reflection of it, but we got some other stuff going on. What else is happening here? Do we have an amplitude changer? No, amplitude is going to be just 1, like the parent function. Do we have a period changer? Nope, so period is going to be 2 pi, like the parent function. We don't have a phase shift in there either, so we're not shifting to the left or the right. We do have a vertical shift up 2, which means my midline is going to get shifted up to 2. So that's not my graph. We're going to go up to 2. We're going to put in our midline. And then from our midline, we're going to have an amplitude of 1. We're going to start at 0 because we're talking about sine, which starts at 0, or in this case starts at our midline. We're going to go down first because it's reflected, and we're going to go down 1 because that's what the amplitude is. So down 1, back to your midpoint, up 1, back to your midpoint. And there's 1 reflected period of this function. And then I'm going to extend it out. So down 1, back to 0. Other direction, I'm going to go up 1, 0, down 1, 0, up 1. Where did that come from? Up 1, 0. All right, here we go. It's going to look something like this. All right. I guess I really should put an arrow that way. It kind of goes that way. All right, what's our domain for any sine and cosine? All round numbers. Our range for this one goes from lowest is 1, highest is 3. So from 1 to 3. All right, that's it for questions 1 and 2. When I get back from picking up my child, I'll continue on with 3, 4, 5, 6, 7, 8.